All right. So in this platform, I want us to consider a typical exam question that we are having, considering our transformation. These are some of the typical questions that you're supposed to consider carefully, whereby they can ask you, like I said on the introduction, you can transform a point. You can also transform a line. So this is our question that you're given. Question number 11. Answer the whole of this question on a sheet of graph paper. Given the line AB as coordinates A, 2, 2, and B, 2, 6, using a scale of 2 centimeters to represent 2 units on each axis, draw axes for values of X and Y in the ranges X is greater than or equal to -6, but less than or equal to 10, and Y taken from -4 to 16. So that is what you're given on this presentation. So what you're going to do is to represent on your graph as you are given 2 centimeters to represent 2 units on both axes. All right, so let us just say we've got 0 here. That's going to be 2, 4, 6, 8, 10, 12, and so on. Okay, you do the same thing on this side, -2. That will be -4, -6, and -8, -2, -4, -6. Same thing on the positive. On the Y, 2 centimeters. Every box that you are saying, that's 2 centimeters. So remember, 2, 4, 6, 8, 10, 12, and so on. So just going to try up to 16. There's something like that. 14, 16, and so on. So that is, you are giving X and Y values according to the instruction that you're given here. So I asked on A, draw and label line AB. So that's our line AB. Remember that you're given before. This is line AB has got coordinates A and B. So A being 2, 2. So let's present our point A that is 2, 2, where X is 2, Y is also a 2. That is what you're given there. 2 on X, 2 on Y. These two, they meet here. So you're going to mark a point. That's 2, 2. Okay, so this is our point A. Okay, then we also have the point B. That is from our given information. We're going to consider B 2, 6. Okay, so there we've got the point B being 2, 6. Okay, that's 2 versus 6. That's our point B. So these two are enough. This part that we are given is enough according to our instruction. Just have 2 points, A and B. So you're going to join A to B. That's forming a line in this case. So you're using your ruler. You join from A to B. You formed a line. That's a line AB. Then from there, let us consider another part of our question B. A1, B1 is the image of AB. So A1, B1, image under an enlargement, center, 0, 0, scale factor 2,5. Remember, I talked about the enlargement, drawing of the image. So I asked to draw and label the line A1, B1, which is the image of AB under the center, 0, 0. So remember, the enlargement concept is not going to change, guys. I said easier path that you're going to use is the matrix object. So matrix times object is equal to image. So you're going to do that calculation on its own. Okay, so there we have got B item 1. I'm just going to do the calculations here, but you're supposed to have it on your graph if it is instructed like that. So remember that the matrix, when multiplied to the object, it must give us the image always, provided that that transformation that you're using, it has got a center 0, 0. You're just going to use it direct, provided that the center is about the origin. If the matrix does not have anything to do with the center, just take the matrix as it is, just like in shear, two-way stretch or one-way stretch. We do not consider the center. So you just take the matrix as it is, but enlargement, there is a need for the center. So center is 0, that is all, center or about the origin. That's the origin in this case, which is 0, 0. So if the center is the origin, this concept is just going to be used direct. Matrix times object is image. It's going to give us the image. And what is the matrix of an enlargement? Remember, from the matrix K, 0, 0, K, that is the Cook. For those who use Cook concept, Patia Cook. It's going to be that where K here is your scale factor. So K, that is the scale factor that we are given, and that is 2,5. So meaning to say, that's 2,5. In place of X, you're going to substitute, in place of K, substitute 2,5. That's same as 2.5. In place of K, you substitute 2,5. That's our matrix. So this matrix, when it multiplies the object, which is our object now, will be the point A and the point B that we are given there. Point A and point B. So we've got the point A, write it in matrix form, 2, 2 in matrix form. The point B in matrix form again, 2, 6. So that's it. So with this concept, matrix times object, we must have the image. And as you consider your matrix multiplication, row by column concept. So meaning to say, the 2,5 is going to multiply the 2. The 0 is going to multiply the 2. We are considering this row. So 2,5 times 2, that is going to give us a 5. So if you multiply properly there, that will be a 5 plus 0 times 2, which is a 0 there. Same 2,5, we are still on this row. At this time, consider this column. So it's 2,5 versus 2 again, which is 5 plus 0 times 6. That's a 0 there. Same thing, considering this row. So that will be row by column again. 0 times 2, that's a 0 plus 2,5 times 2, which is a 5. So that is a 5 again. This row with the last column, so that's 0 times this 2, which is a 0 plus 2,5 times this 6. That will be a 15. So there we're going to have a 15. So that's it. With this, I'm going to simplify, add to have a single value here. That's 5. Here, that's a 5. Another one, that's a 5. Another part there, that's a 15. All right, so this is the image. This was AB. This is A1, B1, the image of AB. Meaning to say, we have the point A1, 5, 5, X versus Y. And we also have the point B1, 5 versus 15, X being 5, Y being 15. These coordinates are the ones that you're going to focus on to have our line A1, B1. With A1 being 5, 5, you mark that point that you are given where X is 5 and Y is also 5. Considering the scale that you are given, you have to put in place the scale that you are given. At the end, you must consider the presentation of your scale at the end. All right, so let us check what we have on our graph here. All right, so that's 5, 5, the first part that we're gonna present. So if we check these values that we are given is just in between, the 5 in between 4 and 6. And also the 15 is going to be in between 14 and 16. So just going to try mark the point that is in between. That is, you count boxes there, 5 boxes between 4, and also 5 boxes between 14 and 16. So it was going to be somewhere 5 here, 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5. It's gonna be somewhere there. So you've got your point that is 5 versus 15. So the first one, it was 5 versus 5. Okay, so this is actually our B1. Then our A1, remember it was 5 versus 5. So that is gonna be somewhere 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Somewhere there. In between 4 and 6. In between 4 and 6 this side. So that is where we have got our A1. So just make sure you have got the proper presentation in terms of the points that you are given there. At the end, you must make sure that the points that you are given are properly presented. Then you can join your points from A1 to B1. So the concept there is on having A1 and B1. The method that you're going to use, it's up to you. But after that, make sure that you indicate properly the points on the Cartesian plane. That is the idea there. All right, then if we check this here, affected our points here. I don't know how, but let's just hope we're gonna be able to finish here. Then here they're saying, actually there is the matrix that is needed. Write down the matrix that represents this transformation. The matrix which represents, so the matrix we already wrote this before, which is the 2, 5. So you're not going to write in terms of K. That is not the matrix they're asking you. Substitute K represents the scale factor. So you must have the proper presentation of a matrix with that constant K inserted like that. So that is our matrix. Then here we are given that this line A to B2 has got coordinates. So we're given the coordinates A2, -2, -2. So there we have got -2 versus -2. And this is B2, -6, -2. So we are going to mark these coordinates. We are asked you to draw and label A2, B2. That is going to mark the points. -2 versus -2. That is the first part. When X is -2, Y is -2. You mark the point, that is our A2. Then we also have B2, which was -6, -2. You mark the point, that's your B2. And from there, you're going to join along this line. That is, we have got our line A2, B2. Okay. After drawing this line, the question is now, describe fully the single transformation, is just one, that maps AB onto A2, B2. So we have got our line AB and we've got the line A2, B2 that we've drawn. So remember our transformations. So if you have to check AB, which is this line AB that you're given, line A2, B2, these two lines are actually the same. The object and the image is actually the same. So they were talking about the isometries. Remember your isometries. Gonna think of the rotation. Gonna think of the reflection. You want to think of the translation. All these are our isometries. So remember the concept of each. In order for you to know that it's a rotation, translation, reflection, first thing, let's join corresponding points A to A2, B to B2, and see what's going to happen between these points that we are given. I mean, the line that you're given there, if you are to join from A, join to A2, from B, you join to B2. So as you can see, the lines that we have created by joining these two lines, they will never meet. These two lines, they are parallel to each other. From A to A2, from B to B2, these two lines, they are parallel. So we understand that if these two lines are parallel like this, and they are of unequal length, because if you check, guys, by just taking a closer look from A to A2 there and B to B2, these two lines, they are not of the same length. So they are parallel and unequal. Which transformation of these isometries? There is only one transformation which we can present, which represents about the lines being parallel and being of unequal length, which is a reflection. Remember translation, they are parallel and are of equal length. They're under rotation, they are not parallel at all. They will intersect. It is a reflection where lines are parallel and of an equal length under these isometries. So that is the one that we are going to consider in our description. So meaning to say, we are going to have our description. It is a reflection. Remember the description of a reflection. We talked about that. Make sure that you watch the videos on the introductions. Then after that, you're going to specify like the equation of the mirror line of this reflection that we are seeing. What is going to be the equation of the mirror line, which maps this line onto this line? So remember, on the equation of mirror line, I said you're going to bisect the given lines. But by just looking into these lines, you can see this is the middle part. This is also the middle part. By just looking into these lines, you can tell. But instead, if you want to bisect, then you're going to do that. But you can tell this is the middle part here. This is the middle part. Then you can join. Because what you want is the half of to bisect, guys, is to find half of the line. So anyways, if you do not understand the concept, that's you're going to bisect. So in this case, I'm going to bisect B to B2. Remember, to bisect a line, you need to open more than half of the line. So this is approximately more than half of the line. We're going to have an arc this side. I think this one is going to be too big. Let's just consider a little bit somewhere there. Here. All right. So you're going to have our arc this side. Okay. And another arc is going to be on this side. So the bisecting part there, remember how to bisect properly. All right, that's going to be somewhere there. So you just have to consider properly your constructions. You do the same thing from the point B. So remember, guys, your concept here. At point B, we're going to also mark our points. All right, back to this point, we're going to have an arc here. So you can see these two, they meet. And also this side, they meet. So it's just going to be your choice. Which line are you going to bisect? Is it A to A2, B to B2? That one, it's your choice about the lines that you are going to bisect thereafter. But with the line that you have drawn, you can even use a broken line to join the points. All right, so that will be our line in this case. So just something like this passing through the given bisectors like this. All right, so it's passing through these bisectors and so on. So that's our line that we are going to have at the end. So you determine the equation. So you have to work with your equations, work with finding the equation of a straight line. But by just mere looking into this line, we can see that the scale is the same. 2, 4, 6, 2, 4, 6. This line passing through this way, dividing our graph into two equal parts, it has got a negative gradient. That is the line of y is equal to minus x. There's another one which passes through like this, through the origin, dividing the graph into two equal parts, 2 versus 2, 4 versus 4, 6 versus, and so on, which has a positive gradient. That one is for y is equal to x. So if you know these lines like that, you can just write the equation, or you can formulate your equation from your basic knowledge about equation of a straight line. So that is y is equal to x. It becomes our equation of the mirror line. So you can actually even write here like equation of the mirror line, equation of the mirror line, that is y is equal to minus x. So that's it. Remember your equations, guys. Make sure that you revise your straight lines. You work on your straight lines as a separate part. D, The transformation T is represented by the matrix 2, 5, minus 1, 0 like this. That is our matrix and maps AB onto A3, B3. Calculate on item 1 the coordinates of A3 and B3. So we can calculate these coordinates. We are given a matrix, even though we do not even know this matrix. Like, which transformation is this? Which transform? Which matrix is this? Like, of all the matrices that we have listed, never saw a presentation of this nature. But that does not limit us because we are given the matrix already. As we need the coordinates of A3, B3, which is the image transformed onto maps this onto, that is the image. Having the matrix and AB, which is our object, it's enough. Because we do understand that the matrix, when multiplied to the object, we're going to have the image. That is the matrix 2, 5, minus 1, 0 times the object, which is the line AB. This does not change. You still remember our AB before, AB 2, 2, 2, 6. So we've got our point A, 2, 2, B, 2, 6. So that's it, considering the row by column concept. That's this row versus this column. Okay, so this row versus this column, 2 times 2, that will be a 4. Minus 1 times 2, that is going to be minus 2. Okay, row by column again. We are on this column now, 2 times 2, that is going to be a 4, plus minus 1 times 6, which is minus 6. This row versus the first column, so that is 5 times 2, which is 10, plus 0 times 2, which is a 0 then. This row on this column, 5 times 2, which is a 10, 0 and 6, that is going to be a 0 there. So that means you can combine this part here, have a single number, plus and minus, that's a minus. So that's 4 minus 6. So you're going to have, 4 minus 2, which is a 2. 4 plus minus 6, that's 4 minus 6, which is going to be a minus 2. So you have to simplify each and every part that you're given. 10 and 0, that's a 10. 10 and a 0, that's a 10. So this is what we are having as our image from the AB that we had. So that will be our A3, and this will be our B3. So the coordinates, you do not leave it as a matrix like this. That's a matrix. The coordinates, therefore, we are talking about the points A3 being 2 versus 10, X versus Y. That's a point. And B3 as a point also, that is X being negative 2 and the Y value being a 10. So that is it. So the question there was to calculate the coordinates only. Item 2, draw and label the line A3, B3. Draw and label now. Meaning with the points 2 versus 10, going to mark your point 2 versus 10, where X is 2, Y is equal to 10. Mark a point. That's our A3. B3 minus 2 versus 10, where these two meet. Mark a point. That's your B3. Join the given line there. That is to obtain, that is to draw the line AB now by joining the points that you're given. So you've got line A3, B3. Then after that, describe fully the single transformation T. Remember, T is the transformation which mapped AB onto A3, B3. And this is the matrix that you are given. If, guys, you do know this matrix, if you know this matrix, you are going to simply describe it. But, guys, like I said, we never had this transformation, like a presentation of a certain transformation which gives a of this format. These two numbers being different like that, no. We do not have. If you have any, just update us. Maybe we're going to work with that. We do not have. But because you are limited on the matrix here does not mean you cannot describe the transformation. If you are given a transformation, let's say you are given 2002 like this. This is a matrix for enlargement. You can describe it as enlargement center 00 scale factor 2. Straightforward. But they were limited because this matrix, we do not even know like the transformation there. What type of matrix is that? So this is what you do. You refer back to the diagram this time. Because T mapped A, B onto this line. So describe from the graph where you can see it properly. Which transformation are we talking about? From the graph. Okay? The object and the image are the same. So we join the corresponding points and see like the presentation there. Remember, these are isometries. I talked about the issue of isometries before on the first part. So in this case, if you were to join, let's say you joined A to A3. So A to A3 is along this line, as you can see. This is A to A3. It's along the line that you have. Then B to B3 is going to be like this. So if you are to see these two lines, they are crossing at this point. As you can see, it's going to be like this. They intersect like this. Which transformation does that? Only talk of a single transformation there. Just one transformation that can do that. Under isometries, it is a rotation where these points can cross the way they are. It is a rotation. So that is a rotation. Now you're describing according to the information that you're given on your graph. D item 3, remember it was item 3. Now you answer it is a rotation. That is to answer the transformation that you are given. Remember, the description of a rotation does not change. You need the center of rotation, and I talked about that. You bisect any part of the corresponding lines, two of them, where they meet, where the bisectors meet, meaning to say you bisect A to A3. But as you can see, guys, A to A3, there's a vertical line where we can see the half of it from A here to A3. That is 1, 2, 3, 4. So meaning to say the middle part is the second box. 1, 2. At the point B, straight here, we've got our line. So if you wanted to bisect, guys, that is where this line was going to pass through. So I want you to try it. But there, as you can see, guys, just a waste of time here. So it was going to be like this. B to B3, it was going to pass. This one of A to A3, it was going to pass through this line. So that is the first bisector that you have. You bisect A to A3 the same way that I did here to bisect A1, A and A2 then. You do the same thing on B and B3. So you open more than half, just like that part you scribed here and here. So you're going to see that line was going to pass through here, the center, like this. It was going to pass like this. If you're going to do it properly, that is how your line was going to be like. So I want you to bisect that properly. You were going to see that the bisector there was going to pass through these points that are indicating passing through like this into the half of this line. Okay, I need here into the half, into the middle part like that. So it was just gonna be like that, and so on and so on. You have bisected B to B3. So these bisectors, the bisector of A to A3, which is this line, B to B3, which is this line, they meet at this point. Where the bisectors meet, remember, I said that is your center. So you're going to have the center of rotation where these 2 points meet, where x is -2 and y is a 6. It's a point. X is -2, y is a 6. That's a point. The center. Then you need the angle now of rotation. By joining to the center, B to the center, and A to the center, we can have our equation. Remember, I talked about this. So you join to the center, B to the center, B3 to the center like this. You join these points to the center here. By mere looking, guys, B and B3 joined to the center, guys, we can see this angle, but it does not need to measure. By looking by side, this is a 90-degree angle here. That's a right angle there. Horizontal and the vertical line, they meet here. That's a 90, straight 90 that we can see. This is a 90 degrees. Yes, we can use a protractor to measure that. That's a 90 degrees. But the direction now, as we are moving from B to B3, which direction are you considering? We are moving this way. From B to B3. B to B3. This is the direction. Anti-clockwise. We are moving this way to B3. That's an anti-clockwise. A clockwise is like this. That's a clock. Anti-clockwise the other way. So that's an anti-clockwise movement. As this movement is happening, it's an anti-clockwise movement that you are considering. That is the idea. So meaning to say, in this case, it's going to be a 90 degrees anti-clockwise. So that's 90 degrees anti-clockwise. That's it, anti-clockwise. Or like I said, on these presentations, how do you present 90 degrees anti-clockwise in short? That is plus 90 degrees like this. It means 90 degrees anti-clockwise. Minus 90 degrees like this means 90 degrees clockwise. A plus, that's anti-clockwise. Anti-clockwise. So in this case, you can also just write it in short, plus 90 degrees. So that's your transformation. You are transforming a line. It's very, very possible. Like I said, you can transform a line. You can transform a point, a shape, a complete shape. It all depends with the question that you're given. So these are the typical questions that you might have till we meet again.